All right. Shall we get started? Okay, so let's go ahead and start. Popular topic today. We were walking in, I thought, we weren't sure how many people were to get here. For those that don't have seats, we apologize. But Pablo and I have a lot of fun planned for today. It's kind of one of these sessions that we've heard a lot about this notion of building intelligence into apps. And what we were talking about this session, we said, hey, one of the best things to do is actually just come in here and show some of the most fundamental coding examples on how to add intelligence to an application. So I think we can have some pretty good fun with this. Now, when you think about this notion of intelligence, at the center of it is data. Data turns out to be sort of one of the most important assets in this, and a lot of people ask why. Why is it data? And sort of the mental model is that, imagine this ability to continuously learn over data that's coming into your system. And the more data and the more loops that you create, the more continuous learning in an application, the more things you can actually do. And a fundamental question sort of arises from this. We hear this often. It's like, hey, if I'm going to build an intelligent application, is that something I should think about as a file new experience? I'm starting from scratch. Or is intelligence something that I can actually add to an existing application? And the answer is both. We see a lot of folks, they'll build an application with the mindset of, I'm going to add a lot of intelligence to this. And then we see a lot of other folks take current apps and add intelligence in some really, really meaningful ways. And really what if you think about it, it sort of centers on this notion of data loops. So for example, let's say you have an application in your business today and there's operational transactional data. There's this notion of continuously writing to that operational store. You can actually add intelligence to that existing data by way of imagine doing predictions and forecasting against operational data. So you could have a transaction loop that's occurring, and then you could bring statistical computation to it to do predictions. There's another loop that's kind of interesting around implicit events. So if you think, for example, if you were skiing, imagine your phone emitting some kind of telemetry every minute on your location, lat long, and that's it. Then imagine what you could do with that information in terms of adding intelligence, potentially redirecting skiers based on congestion to other parts of a mountain that they might have a much better experience at. And then thirdly, there's this notion of explicit choices that are happening, like a loop there. What do I mean by that? Well, you could think of a scenario where, think of like the thousands of people that could be at a ski resort picking restaurants that they want to eat at. Imagine the type of intelligence and data model that you could build around that. So when someone else comes back to pick a restaurant, you have this wealth of information to help them with really, really, really precise recommendations. So with that as a backdrop, when we were sitting with the team saying, like, what would be a fun way to demonstrate adding intelligence to an app, we started off with like 50 ideas. And we ended up on the ski app. So the two of us ski, so we could relate to it. Do we have any other ski or snowboarders here? Okay, so for this will be a good test if you like this app or not. So if you think about sort of adding intelligence to an app, let's use this ski app. For those of us that don't ski, this app is pretty straightforward. Pretty much any resort you go to, you'll find an app like this. The idea is you could look up lift status, you could check snow conditions, you could look at dining options and stuff like that. But let's just kind of walk through 3 scenarios on an app that looks just like this with a before and after. Before, just a standard sort of app, and then after with some intelligence. And then we'll go through and actually build that. So if you think about the first thing the two of us would do with our kids, if you're going to go skiing, one of the first activities is you're renting skis. And in this context, an app that doesn't have a lot of intelligence might look like this. It might have a ski reservation experience where it's really just a matter of you seeing the products, picking a date, entering in what you'd like, and then that transaction is written somewhere. But think about that for a minute. What if you could add intelligence to that operational data? So instead of just writing records into the database, boy, if you were the ski supplier Wouldn't it be awesome if you could run some sort of statistical computation on that operational data to predict to you the amount of ski rentals you'll have based on a variety of factors? So in that particular case, if you've ever been to somebody who's renting skis, we know like that dreaded line where you walk in, you're like, oh no, I thought I got here early enough. And there's several hundred people in front of you and a small staff. Well, imagine adding intelligence where that ski supplier now can see, hey, here's how many ski rentals we're probably going to have in this given week. And then you can change your staffing around that. And then imagine the customer experience, somebody using an app where instead of just getting an order confirmation, you get some sort of signal that says, hey, there is super high demand for the type of skis or the ski boot that you're going for. You should go early. Here's another example. Once we have our skis, now we're ready to go skiing. One of the first things we'll do is check lift status. And this is really all the lifts on a mountain, and typically you'll get something like this. The name, the difficulty, and maybe if the lift is open or closed would be included here. And that's basically it. But imagine if we were to add intelligence here, where picture this app as you're skiing around just emitting your location every single minute. Now imagine sort of doing some sort of predictions on wait times at those lifts. And then imagine doing anomaly detection on top of that data to give somebody a red bang warning that says, hey, you should actually avoid this lift because this is it's an unusual event, and you should go ski over in this different part of the mountain that doesn't have as much congestion. You know, that's a completely different app experience. And then finally, if you think about dining, most all of us at some point have looked up a restaurant. Here's just the classic search. I'm searching for a restaurant. But think about thousands of people going to a ski resort. They make their first choice. You go there. You make your first choice. You have your second choice. You have your third choice. Imagine sort of building all of that knowledge of, hey, if somebody who picks this restaurant is probably going to pick this one and this one to go with it, and continuously learning that each and every day. So when somebody goes to search for a restaurant, instead of a flat list, you have, here's, I'm searching for a grill, and here's the top recommendations to go with it. So with that as a backdrop, what we'll sort of do now is demonstrate, we'll take this ski app, and then we're going to add intelligence into these three areas: ski rentals, lifts, and dining. And then Pablo will walk us through it.
Great. Thanks, John. All right. So we have three goals. Let's start with the first one. So the first one was, it's the day before. I'm getting ready. I want to get some ski rentals. And we want to create signals for the owner of the place so the rental shop is well staffed, and also for the users so that you're not screwed in the morning when you go there and there is a huge line.
Yep.
All right. So why don't we sketch out what this thing looks like?
Yeah, so let's go to the app. You got the app?
Yeah.
Let's see, 6. So let's look at the before.
So here's the app. This is a Cordova app, so it runs in the browser and in the phones. It's kind of convenient for development to have it right here.
So let's go to rental reservation.
All right, there you go.
So pretty straightforward. I can go pick a date. I can pick a set of skis, etc.
That's right.
But like you said, what we want to do here is add intelligence to this operational data so we can predict and forecast ski rentals, and then also inform someone who's rented ski if there's some sort of surge so they know what to expect.
Exactly. So let's go and draw a quick schematic first, and then we'll go through the details. So this is like the quality of the presentation just went down from the polished setup that we had a second ago. Let's think about the activities we need to do in order to make a prediction. So first of all, let's frame the problem. What we want to achieve is we want to know how busy is it going to be tomorrow. And what we know is all of our past history. So the interesting thing about intelligent apps is they're intelligent not because they're particularly sophisticated. They may be very sophisticated or may be very simple. But the thing is they learn from past experience. In this case, past experience is the record of all of our history of rentals. We have all of our years worth of rentals in a table somewhere. This is our transactional system. So you can see there in step 1 that we have the history of all the rentals. And what we need to do is take that. That is a kind of a transactional database. We're selling tickets there, selling rentals. But now we have to perform this analytics activity. We want to summarize that information in a form that then we can use to do do advanced analytics tasks on top of it. So that will be the first step, and we'll go into detail in a second. Once we have the data in a way that is nicely summarized, and also maybe extracted some interesting features out of it, like interesting aspects that we want to understand. Second step is, if we want to make predictions, we need some sort of predictive model. So we're going to create a model. And one thing I want to highlight here is, I don't know how many of you guys have worked with data scientists. We have a bunch in our team. And usually the way it goes is, I'm not a data scientist, I'm an engineer here at Microsoft. And so you sit down with them, you explain the problem, and they proceed to tell you all these words that you kind of remember from college, but they're kind of gone for the most part. So the key thing here is to separate two concerns. There's one aspect that is the mechanics of closing the feedback loop and integrating these models into your application. And then there is the depth of the model. And the depth of the model has no bottom. So you'll make this model better for a very long time. So I don't want to focus on that, because it's usually the first thing you focus on, and then you go deep into that direction. So we're going to build a very simple model. But the important thing is that we're going to build it over the real data we have on the other side. And once we have a model, then we'll proceed to take that model and make it part of the application. So at first, it'll be an exercise in modeling. But then, we don't want to be the model just there for us to try interactively. We want it to be just a smooth part of the rest of the application. So we'll prep the data, create a model, and then integrate the model into the app. Does that sound good?
Sounds good.
All right. So let's start with the prepping the data question. So what I'll do is I'm going to use, so I have my data in SQL Server 2016. Let's take a look at the rentals table real quick. Actually, it's a very long table, so I don't want to do that. Let's do that. So this is what the table looks like. No surprises there. This is which rentals, what type of skis, what is the size of the shoes, and whatnot. So what I want to do with this, if you think about this, from the predictive model standpoint, I don't need this level of detail. What I want to know is, for every day, how many rentals did I have in the past? And then what happened? What was like that day? Did it snow the day before? How was the weather? Was it a holiday or not? Is it a weekday or a weekend? So this is, so the data scientist people say feature engineering. It's a fancy way of saying, let's inject as much context as we can to this information, so then when we build the model has better predictive power. So this looks like a very analytical task, but this is my OLTP store, my relational store. One interesting thing about these newer versions of SQL Server, particularly in 2016, is that a lot of work that we've been doing is around allowing you to do analytical work directly in your transactional store. Let me show you an example here. So this is the base table. So think of this as a fact table. And then I have a few dimensions to deal with. So here's a little view that I prepared that has, it's a typical analytical query where you pivot on your main fact table, and then you resolve all these side dimensions, like whether it was a holiday or not, or how was the weather that day and whatnot. So let me grab this guy and say, select start from that. So this is a nice summary that says for each day, how many rentals did I have, what 1 through 7, what day of the week it was, whether it was a holiday or not, and whatnot. So kind of, this is a data set with all the features in it. Now, I'm running this heavy group by query against my transactional store. And one of the reasons why I can do this, and it's so quick, is so SQL Server has these features to combine these two workloads and make it reasonable to do so. One of them is, if you look at how I initialized this schema, so this is the logic that will kind of create the base schema and all the support objects. And let me look for that. So one of the things I did, in addition to the typical OLTP-ish things I would do, is I'd say, create non-clustered column store index, blah, blah, blah. What that means is, typical indexes, when you say create index, we create a B+3. So those are great for range scans, lookups, and things like that. But if what I want to do is scan millions or sometimes billions of rows and then summarize them super fast, then there are better data structures for that. And column store is an example of that. So if you look here, let me do a show plan. Actually, it's already on. So let me just show you the plan for this. You can see that, so this is the SQL Server plan for it. And you can see that the entire scan pivoted on a single table or a single index. Let me do this so you can see it. because I already created this column store over only the fields that I cared about. So it's a very, very fast scan over that. And I can do that without disrupting my primary workload.
And I guess one of the big things here is that we're not doing a full table scan on your operational data. And instead, you could, with a column store index, which is pretty easy to add, you could be computing over millions of rows, hundreds of columns in the matter of a second. That's the gist of the feature.
Exactly.
Okay, so now that you have this aggregate view, now this is the thing that allows us to go to step 2 of moving that into the model.
Exactly. So we have the data. We did feature engineering, so you can kind of check that box off. And now, so next step is we gotta create a model. So the task of creating a model usually involves a little bit of an exploratory exercise where you go poke at the data a little bit to understand it, and then you try a few models to see which one works best. What tools you use for that depends a lot on your background and what you're comfortable with and whatnot. So there are many options. One of the options is to use R. R is a language that statisticians use a lot. It's surprisingly expressive. You have to get used to the syntax if you come from another background, but it's once you are on it, you can be really productive. In the latest version of SQL Server, one of the things we did is we integrated R into SQL. An interesting aspect of this is usually when you're doing these analytical tasks, you have these huge data sets, and you're going to pull them out and do a bunch of work, and then sometimes get the answer back in. But if you can run this in SQL, then you can run the analytical model straight into the data, like on the same place where the data is. So this is a very nice, very natural setup. So since that works really well from the production perspective, so let's do the experiments in R as well. How many of you guys do R? Okay, I don't feel so alone here, so bear with me while I try. So here's some R. So the interesting thing is, so I'm using R. I'm also using the kind of R services for SQL. So what I can do is I'm going to pull a library and establish a connection string to my SQL 2016 database that is somewhere running on Azure. So what I'm using here is the R tools for Visual Studio, so that you go through a shock process only in stages. So there is R Studio. There are great other tools out there to do R, and you can still use all of those. But if you're just getting used to the stuff, then you can stay within Visual Studio and still fully exercise R. Now I'm going to pull some data from SQL Server, and I can evaluate this on the server. In this case, I'm going to just pull this data down to the client. So if you look at this, this is the view we prepared before. So let's take a quick look here before we go into the details at what this data looks like. So this is just a few rows from the data set. You can see there's the year, month, and day, and a few other features of the data set. And in particular, rental count is, for that day in the past, how many rentals did we have? And this is the variable that we want to predict moving forward. We can also poke on the data a little bit. So we can do simple plots. Like we can say, we have this variable that says, did it snow or not? And let me first show you something, and then you'll see why I'm doing all these other steps here. So I want to plot snow against rental count. And let me make this. So this chart doesn't look right. And the reason for this is, so snow is actually a Boolean. It's like 0 or 1. It's just we're bringing it as a number, but it's actually a Boolean. The system is not treating that as a categorical variable, so you get a weird chart. So let's tell this guy that this is actually a categorical value. So this is more like it. So the question that we're answering here is, do we have more people coming in when it snows, or does it not matter? And the answer is, yeah, a little bit more, not a lot more. So this chart these are quartiles. The middle is the middle will give you a sense of what's the average or the median there. And you can see, yeah, I mean there is some wider range, but in general, you get busier when it snowed the day before. So this is okay data. Let's see if we find better correlations. Then we'll see which ones are useful. So the other thing we can do is, we have this other variable that is the day of the week. This is a number between 1 and 7. 1 is Sunday, and then you go from there until Saturday. So let's plot that guy. This one is much better. There are a few outliers, but you can see that clearly. So the first one is Sunday, and then it goes through the week, and then Saturday. You can see people ski on the weekends. We work, I guess, during the week. I'd take the choice, but it is what it is. So so this is good data as well. Like it tells us these features are not obvious in the base data set because you just have a day of the week. You don't know what it does. But once you poke into the details, you can see that they matter for this context. So given that, we want to construct a model that factors these things in. So here's what we're going to do next. First, I'm going to rewrite these guys as factors, as I did before, so to make sure this thing understands their categorical values. And this, in our operates on vectors. So what I'm saying is convert all of the values for holidays into factors or categoricals, and the same with snow, and the same with weekdays. Great. So now we're going to train a model. To train a model, so now we have a few suspicions on where you should go. The thing to think about when you train a model is you can't just blindly construct train some random predictive model and hope it's going to go well. You have to have a plan for how you're going to validate that the model is within the precision that you're targeting or the quality that you're targeting. So there are, like in SQL, there are analytical functions that do very different types of sampling that are statistically sound models that are well understood. In this case, I'm going to use a lower tech technique, and I'll just say we have a few years worth of data. I'm going to use all but one of those years for training, and then I'm going to take one of the years, and I'm using it for testing. So I'll train the model, and let me show you. Actually, I have a thing here to show. So this is what my data really looks like over the years. So you can see there is the summers in the middle where I have no activity. So what I'll do is I'll use 2013 and 2014 for training, and then I'll make predictions against 2015. I have the actual data. By making predictions against that year, I can compare the predicted against the actuals and see how close I am to the target. And that way, I can evaluate the quality of the model. I got to say, model quality evaluation is an entire topic. There are very sophisticated techniques to do this. Don't do what I'm going to do now, but this is a good way to have an intuition of model quality. OK, so I'm going to separate trained data, which is everything before 2015, from test data, which is everything on 2015. And then from 2015, I'm going to get the count. So this is, imagine a single column table that has all the predicted counts. So then I can use it for comparison later. All right. So at this point, we have two data sets, a training data set and a test data set. What we want to do is create a predictive model. Now, this is when the conversation with your data scientist friend gets really weird. And they'll say things like, oh, for this, you need a boosted decision tree, or you need, are you use a gradient predictor? It gets really weird really quickly. So what I want to do is isolate that conversation. And you have to have it, because the model I'm going to use here is a very weak predictor. But it's great to separate these two. So let me start. I'm going to use a thing called a regression tree. This is a very simple predictor that is, the nice thing is you can debug it easily. You can see what it's going to do very easily. In R, there are a couple of packages that do regression trees. I'm using one of them. And the way you say this in R is you can say, I want to predict rental count. And it's a function of all these variables. So this is not an addition. It's just it's a way to express the predicted variable and all the functions that variable is function of. And I'm predicting over I'm training over this trained data. So let me do that. So now I have a model. So when people say I have a model, they have one of these. And there are different types of models, and you can introspect them differently. Depends on the nature of the model is how you can understand the internals of it. The reason why I'm using a regression tree is because they're very easy to visualize when they're simple, like in this case. So let me do these. So this is what the model learned. I didn't tell it anything. I just gave it the data. And this model is unrealistically simple. But you can already tell that the basics, it already figured it out. It figured out the difference between a weekend and a weekday. It knows about the snow. And it even knows about the seasonality of the workload. It knows that January, February are busier than the other months, just by looking at the data. Real models tend to be, the trees tend to be a lot busier. And you have to do some pruning to bring them back under control. And also, it's very common to create stronger predictors by taking several weak predictors like this one and aggregating them into a stronger predictive model.
But if we took out some factors here, just to kind of play with this a little bit, could we change some factors, change from weekdays or weekends to weekdays, snow, no snow, to see the difference?
Let's do that. It's a good point. So let's see how it does if we change stuff. So let's do a prediction before without changing anything, and then let's change things. So in this case, we're saying run a prediction over this model and with one instance of the data. It says month, day, and whatnot. So if we run this guy, it says, well, we're predicting that for that day, it's going to be in the 40s. So very slow day. So now let's change something. So for example, let's say, so 4 is like what, Wednesday, Thursday? So midweek, slow day. Let's change for a 7, which is Sunday. And let's do that prediction again. And now we're in the 600s or so. So it's just walking the tree and making predictions. And based on that is giving us a number that we can act on. And of course, the precision of this prediction depends on how rich the data set was and how rich the features were. So with this tree, you're not going to get a lot, but with a big tree, you can get really good.
And I think a really interesting thing here for all of us is that, again, we've taken operational data. We're starting to use R to do statistical computation. We're not taking that data out of an operational store and putting it somewhere else to compute over it. This is all happening in SQL. But right. So here's the interesting thing. The nice thing here is that this is probably one of the easiest ways to see intelligence. Why? If we all owned a ski shop, could you imagine having to guess each and every day how many skis you're going to rent versus using these historical trends and letting software do this for you? Then it would help us decide how many people do we need in staff, how much, what kind of materials would we buy. But how do we sort of get this packaged up in a way to feed it into the app? Because the last thing we would want to do is have you sitting around doing this constantly.
Yeah,
right?
I would not take that job. So yeah, so the question now is, we have a model that we like. Yeah. Let's make this operationalized. Let's put it in production. So usually, to decide that you're going to put a model in production, first thing you need to do is validate it. So let's do that super quick. I'll run it against all of my test data this time. And this is not the right way to test for model quality, but just to use your intuition. So this is a plot of the difference between the predicted value and the actual value. And the thing in the middle is 0, which means we got it very close to right. And the ones that are up and top and bottom are cases where we got it wrong. And you can see, intuitively, we got it right pretty often. You can also see that the model is pretty weak because we didn't really nail it all the time. You'll have all these cases where I'll have 15 people stuff in the room and nobody is renting skis. So this model needs some work. But let's say it was good enough. Mm-hmm. So now we're ready to put this into operations. So this is the third step. So we munched with the data bunch until it was ready. Then we created a model that we like, which is this one. Third step is we need to put this as part of the application. There are a few ways to do that. What I'm going to do is I'm going to use the fact that we can run R inside SQL. So I'm going to just put this model inside the database. So think about this. The training data, so not the rentals data we use for training is changing all the time. Mm-hmm. Right? Not every day, but probably every month it may change behavior. So I want to train often. Mm-hmm. So here's what I did. I created a store procedure in SQL. Let me get rid of these charts and this guy. That starts as input, does the same thing we did a minute ago. But then what I'm going to do is I'm going to embed the part of the script that we determined that it was the right one. Usually you arrive at this after iterating on the model. And I'm going to adjust some of the inputs to make it into factors like we did before. And then I'm going to compute my regression tree or whatever regression model you're using for this. And then finally, this is a pretty cool part. So I'm going to pack up the model into a blob. And then what this does is it says execute this R script, and then take the output and stash it into this table, into the models table. So we literally computed a model in memory. We took all the data, we ran this analytical query, took all the data, trained the model, captured the model as a serialized blob, and stashed it in the database itself. So now I have a row somewhere. You can look at that here. Not like you can read the stuff, but there is, there's a tree there. If you can't see it, it's pretty evident. Whatever this is a serialized form of the model. And the reason it's important is because, training these things, it takes, the bulk of the effort is to actually parameterize your model right, and that you do interactively. But then you have your data set is changing, and you want to be able to retrain your model. So you usually retrain it, measure again to see that you didn't regress the quality of the model. And if you like it, then you put it here. And now you have a new model for the app to pick up. So finally, so the interesting thing actually before I go there is, look at this store procedure. This is a regular store proc. So it gets weird up to that point. But then you wrap this up nicely in a store procedure. And then when you want to retrain your model, you just call this guy. And it's regular T-SQL at that point. So last step is let's make something that can make the predictions. For that, I have this other store procedure that says predict rentals. And this is the consuming side of the model. So if you look at what we're doing here, is first I pick up the one row from the models table, the weird hex number there. This contains the model. So I'll take the instance data, and then I unpack my model back into the deserialized model, and then I run the prediction over that. And the prediction will yield a value, and that value is the result of the store procedure. So bam, now end-to-end we have a prediction. So let's wire this into the app, and let's actually run it. So let's go back to kind of normal, C# stuff. So I have an entry point here that we call, remember the app? When we were here, we were setting up a rental. One thing this app does is it checks this endpoint that says, like, should I pop a thing telling people that it's going to be a busy day tomorrow? And right now we say, nah, it's not going to be busy. We know. So we want to do better than that. So what I'll do here is let me wire up this piece of code and walk you through it. So what this says is I'm going to use some information from the context, like whether it is a holiday or not. I could also ping the weather service and say, did it snow yesterday? Is weather looking interesting? And then I'm going to go call my prediction endpoint. And if I drill into this guy, go through the repository, and go down here, you can see that all I'm doing is a regular T-SQL store procedure. No R, no weirdness. But I'm getting the whole predictive model that I built behind these answers. So I'm winding back here. And then what I know is how this is going to tell me how many skiers to expect. And I know how much stuff I need for those skiers. So I can do a little bit of like an estimation of whether it's going to be busy or not. So let's try this out. This is now an async method. So let me rewire this a little bit. There we go. So I'm going to rerun the app, this time with this endpoint wired app. Let's give it a second. There. So let me refresh these. Go here. So then what I'll do is I'll pick like April 1st. So April 1st is like a Friday, weekday, probably not all that busy. And then if I pick the 2nd, which is a Saturday, probably a busy day. So I get the pop-up here. And the interesting thing is there's nothing hard-coded about this. If the behavior of the skiers change or the seasonality of my business changes or whatever, this will adapt to it. So this is something that once it's set up, it'll stay there. And other than tuning the quality of the model, like now I have very nice prediction for
yeah,
good.
That's cool. So that's good job. Thanks. All right. So that's Pablo always gives caveats, but I mean, in what he just did in 10 or 15 minutes, we were trying to do this in a way to show you that's what you can do as well. And again, we just took this operational data. The nice thing about R being built into SQL now, you don't have to go stand up another system. You can literally embed R with T-SQL, execute it over that data. And then this is how quickly, within 10 or 15 minutes, just think about what we did here, is now we can run predictions that would help us from a store perspective if we were renting skis. And then we can also get a better consumer experience in the app. And then you can go back and retrain, et cetera. All right, so let's now, OK, so we rented our skis.
Yep.
Next thing we're going to do is now we're ready to go ski. So the first thing is we go to our favorite lift status. And boy, there's nothing worse than this happening to you if you're skiing. So first off, you've taken all this time to get there. You're ready to ski. The snow's great. Your skis are great. And then you pull up this lift thing. You most likely know what runs you want to get to. But in this context, I'm lucky if I know the lift is open or not. What I have no idea about is there a giant wait time?
Fair.
Right? And if there's a giant wait time, there's nothing worse than getting on, you're there ready to go and you sit in line for an hour.
Yep.
But how could we add some level of intelligence where maybe we pick up, if somebody is willing to opt in, their location, we can start to predict wait times and maybe even detect anomalies to redirect them to different parts of the mountain.
Sounds good. Let's do that. So we have another high-tech drawing for that.
We do. Let's see here. These high-tech drawings. High-tech drawing number 2.
All right. This one has little skiers. It's one of my favorites. All right. So here's the deal here. So let's say, we have this app, you install it on your phone, and we ask you when you install it, hey, would you be willing to give us your location regularly in exchange for us telling you what is a good or bad spot to go to. So you say yes, and what we want to do is following. So every 60 seconds, we'll capture your location and send it to some place. So this is another form of feedback loop. So the previous feedback loop was, let's build on the data we already have. This is the second feedback loop that says, let's build on implicit behavior, implicit signals. People are not taking part here. They just have their phone in their pockets. So we have all these thousands of people sending us these locations continuously. And what we want to do first is collect them all. And for that, what we'll do is we'll push all these signals into Event Hub, which is an Azure service that is great for these kind of distributed scenarios where you have a lot of agents sending you a signal continuously. And this thing scales very well, so you can have a huge audience and still take the load. And once we have it all in Event Hub, we want to process it. That's kind of the second step. And there are a few things we want to do. One is we want to archive this data. This data is invaluable. Think about having the history of where everybody wants to go on your mountain. Like maybe even later, you can do it for investment reasons. Like, should I build more green runs, like easy runs or hard runs? Which ones are favorites for my audience? So I'm going to archive it, and I'm going to find good uses for that later. But I'm going to fork this data stream. One goes to the archive, and the other one goes to the third step. So now that I have a neatly organized data stream, I can run streaming queries over that and say for every one window, do I see accumulation of people in particular locations? And if those locations are where lifts are, like chairlifts are, then I can estimate the wait time within those chairlifts. Not only that, but the result of this is a stream of, for each chairlift, what is the history of wait times minute to minute. So I can watch that, and if there is a change to the wait time, then I can say, hey, something is going on there. And I can help people have a better experience by not getting stuck like Sean hates in the place where you think you're going to ski the whole day, and turns out you're stuck for an hour in this thing.
All right, so how do we wire up this intelligence for this scenario?
So let's start at the beginning. So you would wire this up into the app, but just to show you real quick, since I don't have thousands of skiers around, I wrote a little piece of code that is simulating all the skiers in the mountain, and all it does is it posts the JSON equivalent to this C# class to Event Hub. So it has just the skier, latitude, longitude, and event time. So it's just posting these continuously. And we have a ton of them that is continuously running, and this is the app that has been running since we started talking. So first step, we go to a portal. So what I did is I created an Event Hub, and then I hooked up Azure Stream Analytics into that Event Hub. So I can pull data that is being generated from all these places and landed neatly organized in one place. So you can see this is my input event that lands here. And if I look at the query, there are a few things going on here, but just for now, let's focus on this guy that just says, take the input and put it on the output. So nothing fancy. Except the input is events that are loose all over. And the output I want kind of consolidated in one place. So if I look at the storage account, I'm storing this in blobs. So if I look at the storage account behind this, let's go to archive, and I pick any one of these guys. So you can see how Stream Analytics is taking all of these and packing them in single files. These are CSVs that have all this location history. So now all these big data tools that we have out there, they all work.
Right.
So this is an easy way to organize this information.
But this covers part 1 and part 2. So we have a phone. The phones are emitting every minute.
That's right.
Going through Event Hub, it hits Streaming Analytics. Then the first fork in part 2 is just put all this data in storage in case we want to use it.
Correctly.
For whatever. Yep. Whatever. We might not even have any idea now, but we store it. And then the second fork was something different.
Yeah. So let's think about the second part now. So second part, the question was, how do we know if lines are backing up somewhere? So look at this query for a minute. So what we're saying is we're querying the location events data stream. And in Stream Analytics, we support pulling in reference data. In this case, my reference data set is the locations of all the bases of the chairlifts. So what I'm doing here is I'm saying join the stream of events with the locations of the chairlifts. And I'm making the simplifying assumption that people are sitting exactly at the location. You can imagine like a bounding box thing instead. And then do this tumbling window thing. What that means is do aggregates. I mean, the stream never ends, so you can't aggregate the whole thing. So what this says is do aggregates of 1 minute. And in every minute, give me the chairlift name and the count of the skiers. So the output of this is this nice table, and I'm pointing this add table storage. So the output of this is this nice table that says for every, make this a little bigger, for every chairlift, how many skiers are waiting there. And I know the rate of the lift rate of each one of the lifts, so I can predict how long you're going to wait. So let's wire this up. So the nice thing is all of this it just runs on Azure. Like there's nothing to maintain there. The only thing I need to do is collect the output and integrate it into the app. So let's do that piece. What I'll do is I'll go to the lift controller, and there is a place here where we list all the lifts. And right now we don't have a waiting time prediction, so we just turn it off. But let's wire this up so we can actually have this information. So I'll do two things. One is I have this simple repository that just pulls the data I should show you from table storage. So it's a trivial retrieval from there. And now I have a list of the name of each lift and the number of people that are waiting there. So now what I'll do is I'm going to replace this -1 with an option that says, with a line of code that says, if the place is not open, just say -1. But if it is open, find the corresponding entry in the table and then grab the time from there. And then I have a simple heuristic that, based on the chairlift speed, will tell us how many people are waiting there. All right, so let's build this guy. And then we'll switch over to the app and try it again. There. So I'm going to click refresh here. And this version of the app tells us wait times. So some progress. So now at least you know if it's going to be half an hour, you'll know.
Yeah. No, the nice thing here is as skiers are moving around, again, you're not sitting there. You basically can establish a wait time, communicate it back, which is quite useful. But let's just say, for example, what happens if things are moving slower than usual? Like we have an anomaly, which is the inevitable, don't go here, actually, to get redirected to a different part of the mountain.
That's right. So I just changed my little simulator to do this. We'll see if we catch it at the right time, but we'll see it in the debugger so you can at least see what would happen. So let's say that, so we want to achieve what Sean described. So we want to know if we should stay away from one of these places. The way to know that is to do anomaly detection. So anomaly detection takes a data set and isolates things that don't fit the rest of the data. There are many ways to do that. I'm going to use a very simple way. This is an unsupervised learning technique that just isolates variability from a continuous stream of values. There are much fancier ways to do this, but for now, this simple model will do. And the good thing about this is we have this service built as part of Azure ML, so you don't need to train one. There's one already there. You can use it. So let's use that one. So here's what I'm going to do. The data is already going into a table that tells me the aggregate number of people that were waiting at every 1 minute in the past. So this is a new way to think about applications. So now I can ask these questions that are not about my actual data I manage, but about my own telemetry. So think about what this question is asking. It's saying, go back 30 minutes and tell me how I've been doing for the last 30 minutes. So it's kind of reflecting on your own app and looking at the telemetry of how the thing is going. So now I have a set of samples where for every chairlift, I have 30 minutes worth of samples of how things have been doing. So what I need to do now is run this through an anomaly detector. Again, I'm using a very trivial one. You can get a lot fancier here. But for now, what I'm doing is I'm transforming this a little bit to turn it into a history list. And then I have this very high-level thing called, is the chairlift slow or not? And if you look at the details of that, what I'm doing is I'm calling this analyze async, which all it does is it calls the Azure ML anomaly predictor. So let me put a breakpoint here. This is much easier to see running. What's going to happen is every time you pull the screen with the chairlifts, of course, you wouldn't call this every time. Like, I'm doing it here, but please cache the stuff. Don't do this all the time. So I'm going to go see the history, and based on that, see if there is any variability. So let me go to this thing and refresh it. So when we land here, here's one way to kind of look at this information. If I look at the data, so you can see here, make it a little bigger. You can see here that it was very uniform, and then something started to go wrong. And if you look at the spikes indeed identified correctly like a bunch of values somewhere that were off by a bunch. So let me disable this breakpoint now. So those spikes are kind of derived from the data itself. And you can see here that now it says in red, dude, stay away from the chairlift. You're going to hate it. You can imagine getting a little bit more sophisticated. And since I know where you like to go, because I have all this information, and I have your profile, I can actually send you an SMS. It'll ring your band or something and say, dude, don't go to that one. Go to this other one. It's much better.
Yeah, no, that's awesome. So, as we looked at the before, seeing just a list of chairlifts and are they open or not versus this case, we're predicting wait times. And then really this notion of detecting an anomaly to know that, in this case, we put a red bang in the app just to say, hey, you want to avoid this area. And then getting redirected with a band to a different part of the mountain, that's amazing intelligence. I mean, it's a completely different experience. And once again, this is about a 10 to an 11-minute clip. So let's move to the third part of this idea of intelligence. And so the third part we talked about, all right, we're done skiing. It's the end of the day. We're winding down the session. Now it's time to go eat. And frankly, if you think about sort of the number of people going into a major ski, you're talking like tens and tens of thousands of people making restaurant choices, which on one hand, you could just record the choice. But on the other hand, that's a lot of knowledge that you could build. Yep. Like I could watch a cohort like you picking a restaurant. What's your second pick? What's your third pick, et cetera. So that instead of an app like this where I'm maybe just getting a list, when I go to search for something, I get a really precise set of recommendations to go with it.
Yep.
Yeah. So how do we do that?
All right. So time for our third high-end schematic.
Third and final.
All right. So the question here is how this is a third category of feedback loop where people take action on the apps. Like, for example, you're making restaurant reservations. So you're taking a specific action. You're giving us a signal. So what we want to achieve here is to give you good recommendations for restaurants. And we have thousands of people. So we want to build on that knowledge to make the application smarter. And ultimately, your experience the goal is we'll surprise you by having the app telling you interesting things. So there are 3 steps to this. First step is, again, some data engineering. We need a catalog with the right information about restaurants. Like, what are the characteristics of the restaurants? Are they family-friendly or not? Are they noisy? Are they expensive? We need to have all these features, so then we can make interesting analysis out of that. And the other data set is the actual history of reservations. This is part of the feedback loop. Don't just record the reservation in a table. Like, use this as telemetry, as information that you can use to learn, to have the application learn from past experiences. So that's first step. Second step is we'll take the information, we'll train another model. In this case, this is a recommendations model. So it's a different kind of machine learning model, but still pattern applies. There's a bunch of iterations, some tuning, and then you have a model that you can use moving forward. And then the third step is these models, usually you don't want to run them at runtime. This is true for most of these. You want to train a model, and in some cases, you'll do a prediction on the spot, but the training already happened offline. And sometimes even the predictions you'll do offline. Like in this case, giving one restaurant, I want to go say, what are the other recommended restaurants if you liked this one? And that's a recommendation I can do offline, compute it, stash it in a place, and then use it during while the user is pulling restaurant information. The interesting thing about that is I can combine it with search very naturally, because you're searching for something, and in this context, we're using Azure, so you use Azure Search. But once I found a few items that I like, I want to see what are the other items that I would like if I like this one, even though if there is not a word in common between what I searched and the recommended place. So those are the 3 steps. Let's go through them. So we said step 1, do some data engineering. So let me show you 2 things. Stop the debugger here. First thing is finding my SQL place here. So this is my restaurants table. This is my restaurant table. So it has a bunch of, It has a bunch of data like, family-friendly, food type, level of noise, and the actual name and whatnot. So great. So we have that. And I already pulled from my logs, I pulled the part of the history I care about. So what this says is, this is user ID, restaurant ID. So this says user 35, whoever that is, went to this one and then to this one and this one and this one. So these are the ones that they seem to like, because they're going through this continuously. And I have this history of this. And of course, this data is never this neatly kind of organized. And part of the work is to actually extract this information and put it in this shape. Once you have it in this shape, what we want to do is we're going to train a recommendations model. There are, again, many ways to train recommendations model. If you go to Azure ML, you'll see a lot of options. In this case, again, to focus on the functionality, what I did is I used a pre-built recommendations model that we have as part of the Cortana Intelligence Suite. Let me show you how I wired it up. So first thing I did is I trained the model. And the way I did that is using, again, this service for recommendations. I created a model, uploaded my catalog and my usage facts. And I told the system the catalog has all these features, the file has all the features encoded in it. So train a model based on these recommendations, or rather based on this past experience. And now I have a model. So second step is I want to, in batch, I want to use this information. So I have an Azure Search Index that has all the restaurants, and that's what powers the search experience for restaurants. And I want to wire up the recommendations information there. So here's what I'm going to do. I'm just using the Search Client API, and I'm going to go to my database and pull all the restaurants. And then for each restaurant, I'm going to go to my recommendation model and call get recommendation. Remember, this model is just an exe to retrain it. So you can have a web job that every week or every month just retrains itself. So as I'm doing this, I'm getting fresh recommendations that adapt with people's behavior changes and whatnot. And maybe a new restaurant opens, or the crowd in a given place changes. And then I'm stashing this in Azure Search. So if I go back to the portal, let me show you this real quick. From there, if I go take a quick look at my search index, what I did is I have this restaurant index that has all the typical things you would find from a search index for restaurants, but also has this collection of recommended IDs, which I just computed using the app we walked through a minute ago. So what that means is, let's do an interactive query directly in the portal to try out the search index. So I'm going to search for grill. And as part of the full text search response, yeah, of course we did keyword search on the actual thing we searched for. But you can also see that the pre-computed recommendations are also in place. So that means that when you're serving results to the client, you can serve the results, and you can serve recommended related items. So if we go back here, so then I can come here and search, and this was wired up. And then when I drill into one, not only we can present this information, but we are recommending a set of restaurants based on kind of the wisdom of the crowd. So all these other people that have done the same thing before.
Yeah, so this isn't you and I sitting there making these choices. This is literally the machine learning sort of behind the scenes, sort of coming up with these recommendations. The other thing that I think is really interesting here is if you think about it, if we were to add restaurants to that first part of this this scenario, not a big deal, doesn't sort of mess up our app. And at the same time, if people change their mind and the behavior of what they used to like, and they change, I like this restaurant now, and here's this set of other restaurants I like, all of that is just the intelligence of that's what we meant by data continuously learning behind the scenes. It would completely change sort of the app experience in a really cool way.
That's right.
Cool, thank you.
Yeah.
All right. So hopefully we demystified this notion of adding intelligence to apps. We wanted to have fun and use a ski app. I think we're even going to try to get this app packaged up and posted somewhere. But we really wanted to show you how simple it can be in a sense of just taking a current app, adding intelligence to it. It sort of can have a profound impact on any business. If you just sort of look at the set of building blocks, we always like to think of these building blocks. But today we're using SQL Server with R. We use blob storage, Event Hub, streaming, analytics, etc. These are just a set of building blocks we happen to use today. But there's a bunch of other building blocks in Azure.
Yeah, I mean, think of this as there's two layers of components we use here. One is Azure is full of components that are infrastructure elements that make storing and manipulating and managing data in general a piece of cake. And then there is this higher level layer of services that do things like here is a time series, please predict it, or detect anomalies and whatnot. There are these very high-level services that give you options that are pre-canned, like in the Cortana Analytics or the Cortana Intelligence Suite, where you can find a recommendations model. Or there are advanced building blocks where you have full control of the whole situation, like running R services in SQL or creating models with Azure ML.
Yeah, no, it's awesome. And then for this group, I mean, I just look at the group that's here now. I would argue you can be some of the most impactful developers in your entire business. Why? Because this, if you think about sort of adding intelligence to an app and what it can do, while we demonstrated it through a ski app, sort of if you read from left to right over the page, boy, you can add intelligence in so many places. If you think of forecasting, this idea of demand generation, revenue forecasting, growth predictions that come along with it, boy, that's a completely different world than looking at static dashboards trying to guess what's going to occur. You can really use the power of data learning, continuously learning from itself. Or if you think of anomaly detection in banking, pretty much any bank here that you're going to talk to that's building an app, fraud is generally conversation number one. But being able to detect fraud on the fly and use statistical computation in really meaningful ways, or to discover supply chain delays, once again, something like Columnar technology comes in. Could you imagine if you could ask a question across your entire supply chain that could involve, 600+ billion calculations in the matter of seconds? To get a response? Or could you imagine, as people are actually buying products from a retailer, where you're running some sort of statistical analysis on that operational behavior as it's happening in real time? That's profound. It's very different than the way we might have thought about it in the past. And then finally, these experiences that we can get are remarkable. A ski app saying to you, not just the lift is open or not, but actually directing you to stay away from something, and you're going to have a better experience on the fly. Imagine a ski resort that offers an app like that and a ski resort that doesn't. And that's really what we mean by companies who embrace data and build these intelligent apps can have a profound, profound impact in their businesses.
So our call to action is Monday, you get back to the office, you go through Swag, you tell the stories, and then go pick an app that you maintain, maybe an app you work on, and think about what intelligence you can add to it. Hopefully, we succeed to the main takeaway of this talk, which is adding intelligence to an app is not about getting super fancy or sophisticated on day one. It's about thinking about how the app can learn from its past experiences and adapt its behavior. And small incremental steps can get you there. So a few examples, like instrument your app, start collecting behavior information so you can do better later. Maybe check out some of the Cortana Intelligence Suite pre-built options, so you can, if they line up with your requirements, maybe you get something off the ground quickly. And if not, maybe go check out Azure ML. There is a ton of examples. It's a very rich gallery of ready-to-go models and kind of templates that you can use to experiment with, and maybe add something that will surprise your users. If you manage some sort of content that people have to look through, think about adding search and recommendations as a natural way to interact with your app and offer something before they thought about it. They're going to go like, how they did that? And you do it based on data. And if you feel edgy, take the latest RC build of SQL Server 2016 with R services, and then you can start trying to really mix operational stores with analytical queries, with statistical models to create the next generation of advanced analytic applications.
Yeah, it's awesome. So huge thanks for your time. If you can give us your feedback on the evaluations, we'd really, really appreciate it. We're almost at the top of the hour, but Pablo and I will actually hang out up here up front. Anybody who has questions, please go ahead and join us up here. So thank you so much.
Thanks.